Infrastructure as code has been there for long and still very popular. To set up your infrastructure, you define the blueprint of your infrastructure in form of some code. For example, in tools like Ansible and Chef, you define your YAML, which defines basically how your infrastructure is going to look like. You used to configure your virtual machines, hypervisors, servers, even your apps or network devices using tools like Ansible. But in 2025, when even we don't want to code, do we really want to define our infrastructure in form of playbooks written in YAML in, for example, Ansible? Can't we do it via a prompt only? Here we are going to discuss a new approach called infrastructure as prompt. And when I say prompt, as we all know, prompt could be anything. Prompt could be your text, your image, or even your voice. So in this video, we will define a simple infrastructure in form of a diagram, and we will supply this diagram as a prompt to our AI agent. And we will evaluate is the AI technology is matured enough so that it can actually replace the infrastructure as code approach with infrastructure as prompt. On the screen, what you are seeing is a very simple infrastructure which I have designed using a tool called Draw.io. Draw.io is a simple tool where you can prepare your flow diagrams, your mind map, and a lots of things you can do. Here you can simply export it, and what I have is this image. I'm going to supply this diagram of my infrastructure to an AI agent, and we will evaluate whether my AI agent is capable of identifying all the components available in my infrastructure, relation between them, and other minute details. And do I finally get my infrastructure up and running? The AI agent which I'm going to use in this video is Gemini AI Code Assist, that CLI one, which you can use for free. And I think in current market that provides you the most generous amount of quota of AI request which you can make to get your coding done. But here we are using it for some different purpose. I'm doing an experiment. Let us see how it goes. But before we proceed and feed this diagram to Gemini, let us understand this simple infrastructure. This is basically a DevOps use case where you are going to monitor your some devices. They could be your virtual machines, your applications, or anything. For the people who do not understand all those tools, I will tell in very brief what these tools do. So on the top, we have Grafana. Grafana basically is a visualization tool which is able to draw the graphs, the pie charts, and various other visualizations. Prometheus is a time series database. So for example, what is your CPU usage at this point of time? What was it after 5 minutes? What was it after that? So it maintains such a database, and Grafana can integrate with Prometheus and can draw the graphs for the CPU usage metrics, for example. But there can be number of metrics which you can monitor. And in the middle, you see this is a mimicking of a firewall. I'm using NGINX server to mimic the firewall rules. And at the bottom, I have some node exporter containers. So where does this Prometheus gets its data from? So it gets its data from various kind of exporters. It has number of exporters which can integrate to Prometheus. But here this node exporter container or exporter or agent, whatever you want to call it, is very popular when it comes to system resource monitoring. So I will run these exporters in containers. Basically, in real life, you run these containers inside your device which you want to monitor. It could be any machine which you want to monitor, but I'm just directly for the demo purpose running it in form of a container. You can directly run the node exporter container, and there are ways. So they have their own images. You really need not to run a Linux first and then install node exporter inside. Rather than you can directly run node exporter as a container. And I have a backup directory, the local directory as well in my infrastructure. For what? To take the backups of Prometheus configuration and the firewall rules as well. So these are the top level components in my infrastructure. Node exporter supplies data to Prometheus. There is a firewall in between which will only allow requests coming from Prometheus to node exporters. And finally, we will see a dashboard, a visualization in Grafana. And whenever user want to trigger a backup, so have a look at these small text written on the top of arrows. So that will also guide our AI assistant or AI agent to build our infrastructure. I'm writing here is backup whenever triggered by user. So it won't be any automatic backup. So it will automatically find out which config I should backup in general from Prometheus and what kind of rules should I backup from my mimicked firewall. Have a look at this text. So when it comes to Grafana and Prometheus integration, so there are two things which you need to configure. One is the data source, where this Grafana is getting its data from. It could be Prometheus, it could be InfluxDB, it could be XYZ. There are a number of data sources from where it gets its time series data to display the graphs. So I'm writing here automatically configure Prometheus data source automatically, and also node exporter dashboard as well. So whatever data is being supplied from node exporter, there has to be some dashboard, graphs, pie charts, bar graphs, whatever it is. So we have in public domain an open source or free node exporter dashboard as well. So I'm instructing here in this diagram itself that you should do these things automatically. Otherwise, if you have any experience with Prometheus and Grafana, these are the manual steps which you will have to do, or you will have to do some scripting to do that automatically every time. Also, Prometheus will have to know where to get data from. It will get its data from node exporters, but it will have to know their addresses. The similar thing I have written here in the form of text. Automatically configure node exporters in Prometheus. I'm expecting that it will get automatically done by AI. And I want everything to be running in various containers. So I have put a small icon of Docker container on each of the component, except this thing, this will be a local directory. All right, this was a brief about my very simple infrastructure. Let us go to the actual thing. So I have created a small project, although we are not going to code anything. We are totally relying upon the prompt. So the most important thing is this draw.io file. I have just opened that directory in VS Code. You really need not to use VS Code. You can directly see it in your, for example, here in your file browser, whatever you are using. But in VS Code, you can see your files that are being created in the runtime, and also you can browse your containers as well. So I was running it already. I will stop them first. All right. So I have this thing. I have cleaned up whatever I was experimenting with before. So this is my draw.io file where I have defined my infrastructure as a diagram. By the way, you can call it infrastructure as a diagram as well. But in AI, everything is prompt, whether you send a diagram or voice or regular text, whatever. So I just exported it. I could have supplied draw.io itself to AI, but somehow it works better with the images, PNG or SVG alike formats. So I exported it in form of PNG. So this is the image which I was showing you. This is how it is being displayed in VS Code. You can choose not to use VS Code at all. So what I am going to do is, I'm inside my project and I will start Gemini. I have set up my Gemini CLI already, and I'm using free account, and it gives you enough requests per day so that at least I can make this demo video. All right, I authenticated and I am into my Gemini account. You see this 2.5 Pro model I can use, and it is saying 100% context left. In my experience, even for your daily coding job, totally it is, subjective to everyone, but it is reasonably sufficient actually. All right, so I have this diagram and I have also this instruction file. So this you can consider to be a additional prompt which will be considered or will be sent to AI. I will instruct Gemini to read these instructions. By the way, the Gemini documentation says you can make this file and it will be automatically read. Some places it says like the file name should be .gemini-instructions.md, but sometime it doesn't really consider it. So for that, I explicitly write the prompt that your instructions are in this file. So also adhere to these instructions while serving the user request. So what are these instructions? I'm just telling Gemini Code Assist that you are a DevOps engineer and you will receive some task related to infrastructure building. I want to have some backups. So in this system prompt, you can say, I am just instructing whenever you want to create backups, create it in this folder in the format like entity name and the timestamp at what time the backup was taken. For example, if it is backing up a config file from Prometheus or creating a rules backup, it will put a timestamp at the end. And another is generating the code. So as we can coding agent, it will generate a lots of tools as well on the go whenever it feels like. So where it should go? If I will not write it, it will be scattered all over in my project. So I have strictly given the instructions whenever it is going to generate any code, it should go inside this AI generated code directory. That's it. Let's start. I will write, please create my infrastructure as defined in file. You put @ then it will display all the files available in your current directory where you have launched your Gemini from. So I want my design to be look like design4.png, and also adhere to instructions given in again @gemini.md. So I am explicitly telling it about the instructions to follow from this file. That's it, and nothing else we really need to provide it with. My network diagram is working like my source of truth. Enter, and we will have to wait what it creates. During the creation, it will tell you what it is going to do, and that's really interesting to read time to time. Before we proceed, let us see. Create Docker Compose file. Very good. That's I really want to have, because I have several containers. Configure Prometheus to automatically discover and scrap metrics. That's what I gave it as an instruction here. Do automatically configure and define, for example, scrapping interval. Provision Grafana, set up NGINX firewall. So it has basically read the design of my infrastructure correctly. Now let us go forward. So, and also it is generating code inside this AI generated code folder only. That's very good. Again, so it want my permission to create those directories, so I don't want to approve it again and again, so I will do it like allow always. I have created. Now I will create Docker Compose file that defines all the services. Go ahead. So these are the code changes it is going to do. That's why I prefer to have VS Code. You see everything happening in front of you. That wouldn't be a case if you open a browser, file browser here, and then operate it on a CLI. So I'm maximizing the CLI again. I really don't care what it is doing in behind and what it is generating. It is asking again one more permission. What it want to do is it want to write some file. Yes, again, always allow. Let it do its work. So it has already started generating various things, as you see: dashboard, data source, nginx, rules. At this folder it has created for by now. Prometheus, Docker Compose file. Now it is doing a web search as well. Grafana node exporter dashboard. You remember we told it that Grafana should automatically configure with the node exporter dashboard. We don't really want to do that manually after the tools has been started. So it was taking too long to download the node exporter dashboard. I don't know what is the reason. I'm not sure if it is because I'm using a free account, but what I will do is it has already done did a search that dashboard ID is this one, but it couldn't download it somehow. So I will download it manually and instruct the Gemini that I have downloaded it for you. Now you just need to configure it in Grafana, for example. So I will try to find the node exporter dashboard, for example. Node exporter full, yes, that's what we want. Yeah, 1860 is the ID. It was correctly identifying the ID at least. So it is saying the search result pointed dashboard ID, this one. I'll fetch the JSON from Grafana website, then save it. So it was trying to do that, but it couldn't do it. That's okay. We can help AI so that AI can help us. So I'm going to download this inside my project directory. Save, and I should see it here. This is the one. Now what I will see it, you were taking too long to, although you really need not to write that much, I am just trying to be descriptive to AI so that it is more accurate or it doesn't confuse.
Too long to download the node exporter dashboard, so I have downloaded it for you. It is in the project root called, this is the name. Now configure the Grafana with this dashboard.
All right, I mean, spellings they can correct by themselves. By the way, it keeps on creating some funny messages while generating the response and doing its job. It is taking too long. Let me try again.
Why are you taking so long? You just need to perhaps copy this JSON dashboard.
It looks it has now copied, and Now it is building firewall. So it is building something inside Nginx, not anything yet, but let us see. Revising network configurations, this and that. So it has passed the step for configuring Grafana at least. Implementing the proxy logic, defining the configuration. Still no files inside it, should be soon created. Okay, Prometheus it has created already. Okay, Prometheus YAML has been created, the config file. Now I see Nginx conf, it has also started writing. Preparing execution also. Any containers created? Not yet. Okay. This completes the setup of your monitoring infrastructure. Let me know if you have any other requests. I would say bring up my infra now. Okay, start.sh is the script for bringing up everything, I believe. All right. Docker -compose, it's an old thing. Docker space compose, it should have used. Now it is searching for web for Docker -compose, how to install it. So it should find it, I believe. It seems Docker -compose is not installed. It's Docker compose, not Docker -compose. Okay, I have helped it, otherwise it would be trying to install this thing, then again failing. So yeah, you help AI and AI helps you. All right. It will now modify start script. Good, because I'm automatically accepting the edit, so it is not really asking every time, shall I update this file, that file. So now it is executing the deployment. Do I see anything? Not yet. So finally it says infrastructure is now up and running. Let us check it out. Oh, I see all the containers. So if I go back to my diagram, there should be 3 node exporter containers, 1 Grafana, 1 Prometheus, and 1 Nginx firewall. So 3 plus 3, 6 containers. Yes, Prometheus, 3 node exporters, 1 Nginx firewall, and 1 Grafana. Perfect. Now it's time to test it. Is it working as we expect it to? It is my old instance, so I will refresh it. I know the port where it should have started. Otherwise, you can ask Gemini itself. Tell me the web URLs for each and every tool or container you have started. So it will ask for login, admin default password reset, you can skip for now. And we are into something which looks like a dashboard. This is the node exporter dashboard, which it was taking too long to import. Now why it is not showing it perfect now? Okay, now I have selected it again because we have just started it. So for some graphs you won't see any data, but we have a refresh time of 1 minute. Maybe let me make it a bit less, 10 seconds. So every 10 seconds it will refresh your panels so that they will fetch it the data from Prometheus time series database. But it is working fine. So we have a job called node exporter. I will not really go into the depth of nomenclature of Grafana, what is job and what is data source. But the main thing is, like, there are 3 nodes which it is polling. Node exporter 1, 2 and 3. Now let us have a look into the code, what it has generated actually. If we go in here and try to see the rules it has created, we see 3 server blocks in NGINX that has been started. I believe these 3 are for our 3 node exporters, because we want these to be accessed by Prometheus, and we have some rules created inside it. They will be listening on 9100, 9101 and 9102, I believe. Yes, and it will allow only the traffic coming from this IP, and this IP, I believe, should belong to the network created for this Docker setup. Let's have a look. It's a monitoring network that has been created. It hasn't assigned the IP or the network address for this network, but this is automatically assigned IP, and it has automatically detected that I will have to allow the traffic coming from this address. That this address has to be of Prometheus. Accept this traffic, deny all, and where it will get its data from, it's this thing. This is a service name as defined, as created by the AI in here. This is my Prometheus service, this is my Grafana, this is the service name node exporter 1, and it will expose the port only 9100, where you will get your metrics from. So this has done really a nice job while creating firewall rules. Similarly, for the next exporter it has created, NGINX here will listen on those 3 ports, 9100, 9101, 9102, and it will allow the traffic coming from this container only, the address of this container only, and it will map it to their individual ports. You see, the ports of individual node exporter is same, because the service here is listening always on this port 9100, but in the NGINX we have 3 different ports for these 3 different exporters. So it has done a really nice job to create the firewall rules. And here you can see the services in the Docker Compose, NGINX firewall as well. So it is exposing that many ports. Using this infrastructure as a prompt approach, we can make really complex infrastructures which have a lots of devices, a variety of devices, a variety of configurations which you will have to do. And that all you can do using a single prompt written in natural language, or as I have demonstrated, in form of some diagram, which is really handy. And making a diagram is way easier. The diagrammatic approach I really liked, because at the end your infrastructure is more clear in form of diagram rather than a text. Imagine if you would have done the same infrastructure using a prompt, you would be writing 2-3 paragraphs of the text, which to understand you will have to read it through, but diagram is so clear. I hope you liked the approach of infrastructure as a prompt and you found the video informative. Let us see us in next. Thank you for watching.